Here's an example for payback. We've got Patriot Theaters, and they're looking at the Boston Multiplex. Put in $550,000 today, and cash flows of 100, 200, 300, 400,000 in 1, 2, 3, and 4 years. And would the firm choose to do this project based on payback? Cost of capital is 23.4%, and the payback limit is 2.9 years. Well, notice we're about to solve for payback, and that cost of capital is not relevant. So what goes on here is they put in 550. That's how much they need to get back. Again, this is a conventional cash flow. They put in 550. They expect 1, 2, 3, and 4. Those are all positive. C0 is negative. That's the initial investment. C1, 2, 3, and 4 are positive, conventional. So in year one, they expect 100,000. They went into year one needing 550. They expect 1. So in 1 year, they expect to still be 450,000 short. Year two, they expect 200. At the beginning of the year, they need 450. Expect 200 during the year. They're still 250,000 short. And again, you can see that 100 plus 200 is 300. If they need 550 and they only expect 300 through the first two, they'll be 250 short. Year three, they expect 300. They went into the year needing 250 and they expect 300,000. So in 3 years, they will have overshot it by 50,000. And again, you can see in the first 3 years, they expect 600,000. They only need 550, so they're over by 50. So when does payback happen? Well, they need 250,000. In year three, they expect 300. So again, we've got our machine, and so we put in 300,000. 300,000's in our machine, and it's going to spit money out. And how long will it take before it spits out 250? 0.83% of the year. So payback is 2.83 years, which means we get our money back before the limit of 2.9, and so they would accept the project. They would pursue it. And so again, why is payback 2.83 years? Well, in 1 year they'll have gotten 100. In 2 years they'll have gotten 200. And then in 0.83 of that third year, they would have gotten 0.83 of 300,000, which, it's really 0.833333, is the last 250. 100 plus 200 plus 250 gets us our 550. How about strengths and weaknesses? The biggest strength is really just that it's easily understandable and intuitively appealing, especially folks that are really not finance folks in the sense that they're not familiar or they're uncomfortable with the concept of time value of money. It's just if I'm spending $100, how long does it take me to get my $100 back? There's no discounting. There's no, it's just how long does it take me to get my money? In practice, it's particularly useful for small projects. A lot of times the benefits to being able to compute the analysis by you basically using very few resources can outweigh the costs of really not focusing on value. That's in practice in this class. We always focus on value, but in the real world, if you're making a small decision, oftentimes you can do a quick back of the envelope calculation. You may get it wrong, but it's probably not going to be that big of an issue, especially if you're dealing with small projects or small issues, and then you can move on and focus on something that has bigger implications. Lots of weaknesses. No time value of money, no discounting. Project risk may not be taken into account. There is no involvement of anything risk related in setting the threshold. The threshold is simply based on managerial discretion, not on economic principles, and so it's really what the managers are comfortable with. If there's non-conventional cash flows, then it's not even clear how you would apply the method. Again, with conventional, it's negative, then a bunch of zeros and positives. You put your money in, and then how long does it take to get it back? But what if you started out by getting money and then paying it back? And what if every other year, 1 year you got money, 1 year you paid money, 1 year you got money, 1 year you paid money? It's not always so clear how to apply those. You can, but it requires, some manipulation. If you have conventional cash flows, the rule can lead you to make two kinds of mistakes. One, you can reject projects that create value. Suppose that your payback threshold is 2 years and you have a project where you put in $100, then you expect 0, 0, 0, 0, and then $1,000,000. And we'll assume it's a reasonable 10% cost of capital. That project has a massive NPV. The problem is it takes you 1, 2, 3, 4, a little over 4 years to get your money back, so you would reject it. What happens is payback is always going to reject projects where a lot of the benefits happen late in the future, after the threshold, because it's not going to take those into account. And when you have very few early, you're not going to get your payback back in time. The other thing is you can accept negative NPV projects as you're not discounting. So again, suppose the cost of capital is 10%. You payback period's 1 year. You put in 100. In 1 year, you expect $105. So payback happens in slightly less than 1 year. And so you'd accept it because payback happens faster. But if you did the NPV on this, you would see that negative 100 plus 105 divided by 1.10 is actually less than 0. We're counting the 105 in a year as 105 when we really need to count its value, which is 105 divided by 1.1, which is less than the 100 that we put in. So payback can make both kinds of mistakes. You can miss out on good projects, and you can take on bad projects.